Hello everyone. We're going to practice some rearranging formulas. You make sure that you have a piece of paper and you're doing everything I do on the piece of paper. When you're done, I'm going to give you 2 problems to solve on your own. And you're going to turn in this practice sheet as well as the problems that you're solving on your own to the bin when you return to class. And I will take a look and see if you understand how to rearrange formulas, okay? I love rearranging formulas because rearranging formulas is really just showing your knowledge of order of operations. So let's remind ourselves for order of operations, we go ahead and we use GEMS. Some of you may use PEMDAS, but it's the same thing. This is our groupings. This is exponents and their opposites, which is taking the square root, multiplication and division, and subtraction and addition. All right, so I'm looking at number 1, and it says that we need to solve for V. And I notice that V is on the bottom of our fraction bar. Well, we're going to want V to be on the top because we don't want to solve for 1 over V, right? We want V, which is an implied on top of a fraction. So what I'm going to start off by doing is I am just going to multiply both sides by the inverse or reciprocal. So we have V on the bottom. The opposite of that is putting it on the top, and M's on the top. The opposite of that is putting it on the bottom. This is the same as dividing both sides by M over V. Remember, we have keep, change, flip. So just remember, multiply by the reciprocal. So if I do that to this side, I must also do that to this side because of our property of equality. So I'm going to have V over M. So what that gives me here is, since the D, I can go ahead and set that up as a fraction. This is going to be dV. I'm going to use a different color. Okay. So we will have dV, and now all I'm doing is I'm just rewriting it in alphabetical order, and on the bottom, M times 1 is just M, and that will equal, well, this all canceled out, so anything times itself is going to be simply 1, okay? Let me do that on the side for you. So we have M over V times V over M. So that really just equals MV over, and this is VM, which I'm just going to change order. And anything divided by itself is 1, okay? So you don't want to put a 0 here. Make sure you understand that. All right, now we want V to solve for V, so I'm going to get rid of this. So once again, I'm going to multiply by the reciprocal. So I'm going to put the M on the top of the fraction and the D on the bottom of the fraction. What I do to this side, I must do to this side. So I'm going to have M on the top, D on the bottom. This will become 1, leaving us with 1V, which we'll just write as V. And on this side, 1 times M is simply M. And again, there's an implied 1 on the bottom, so 1 times D is D. And there we have our final answer. Okay, let's take a look at number 2. So this time we want to solve for H. Well, I see that what we're doing with H is we're multiplying it by W, L, and 1/3. I'm going to deal with my fraction first because it's a number. So I am going to get rid of that first. So the opposite of multiplying by 1/3 is multiplying by its reciprocal, which is 3 over 1. If I multiply this side by 3 over 1, I have to multiply this side by 3 over 1, which is just 3. And since I don't have a fraction, I'm not going to write it as a fraction. So over here, we're going to end up with 3V, and on this side, 1 divided by 1 is 1, and 3 divided by 3 is 1. So that will just leave us with 1, and anything times 1 is itself, so I don't need to write it. And we have LWH. Now we want H to be by itself. We always have to keep the eye on the prize, okay? So H is the one we want by itself. So I'm going to do the opposite of multiplying H by LW, and I'm going to divide it by L So I'll divide both sides by LW. And on this side, LW divided by LW will just become 1. That will leave us with 1H. And over here we have 3V over LW. Because we can't do anything with that, because none of those are like terms. Now to put it in standard form, I'm just going to go ahead and reverse the order. So I'm going to say H equals 3V over LW. Now on the assessment, when I saw this, a lot of you had left it in this form. I just want to talk to you about this. You had H equals, let's see, how did you do it? V over 1/3 LW. So you understood that what you were doing is dividing all of this. This is technically the same thing. The problem is this is not in simplest form. And remember, if you can do anything mathematically, you must do it mathematically. So because this is a number, we would want to work with that number. So I don't want to have, essentially that's 1 over 1 over 3. So that's 1 over 1/3. And we know that that really is the same as 1 divided by 1/3, which again is keep, change, flip. And so that would be a 3, and it would end up with a 3 on the top, okay? And so we don't want to leave it in this order because it's not done yet. There's some more math that we can do to that. Okay, let's take a look at, whoops, a couple more. All right. So here we are solving for B. If you ever have a highlighter, sometimes it's nice to highlight what you're solving for. And this time we're going to notice that B's are on both sides of the equation, which is going to make it one extra step, okay? So just like we do if they're all numbers, the first thing we do is we simplify each side of the equation. So I'm going to look at this expression over here. That's already simplified. I can't do anything because those are not like terms. But over here we can do the distributive property. So that's what we're going to do. So I'm going to write down A, B minus C. Just carry that down. And then we have Y times B. I'm going to put it in alphabetical order. Minus Y times Z. So Y, Z. All right. So again, remember, we are trying to solve for B. Now both sides of the equation are in simplest form. So our next step is to put all of the B's together on one side of the equation. So I'm going to take this one and move it to this side. So I'm going to subtract BY. And if I subtract it from this side, I have to subtract it from this side because of our addition-subtraction property of equality. Now, on this side, I'm left with 3 terms and none of them are alike. So I am going to go ahead and just rewrite them. And I'm not going to worry about standard form quite yet. I'm just going to rewrite everything down because we know this is going to continue changing. And on this side, that cancels out, leaving us with just negative YZ. Okay, so what can I do here? Well, I want to keep the B's. So I have 3 terms. And this term does not have a B, so I'm going to go ahead and move that to the other side. So I'm going to add a C to both sides. So that's going to leave me with AB minus BY equals, and these are not like terms, so I'm just going to go ahead and write it as C minus YC. All right, now what to do over here? I have a B here. And I have a B here. So we're going to factor that out. We're going to do more with factoring later on. So I know we introduced this to you early, and hopefully you'll remember a little bit later when we talk about it more in depth. But since both of these have a B, I'm going to take the B out, and what do I have left? I have A minus Y. And now think about distributive property. If we were to distribute this back, you would see that we have AB, and we'd have negative BY. So you can sort of work backwards because I know you know distributive property quite well. And over here we haven't done anything, so we have c minus yc. Now we're just going to think of these as two different terms. Since I want b by itself, I need to get rid of a minus y, and since we're multiplying, the opposite will be dividing. So I'm going to divide it by a minus y. What I do to one side, I have to do to the other side. And so that's going to leave me with b on this side, because anything divided by itself is 1. Even if it looks strange, it's still just 1. So we have b equals, and on this side, I can't do anything. I can't simplify it at all. I have to leave it just like that, because none of these they're not all like terms. So we have c minus y over z, and then a y. And I'm going to say there's my end answer. Might look strange, but we're not going to worry about what they look like when we're solving for variables. The variable is isolated, and so I'm done. Okay? So let's go ahead and take a look at this one. This is a lot like the one we did up above. So this time we are solving for x, and again we have x on both sides. So we're going to start by simplifying both sides of the equation. This is already in simplest form, so let's just go ahead and write that down. And over here we can do distributive property. So we're going to have ax minus ay. Now that's also in simplest form. So the next thing we always do after we've simplified both sides of our equation is we get the variable that we're solving for all on one side. So we're going to move these to the left. So minus ax minus ax. Right, so on this side, all three terms are different. We can't combine anything, so we're just going to rewrite it down. Cx minus ax minus d equals, and on this side, those canceled out to be 0 and 0 minus anything. We don't need the 0. It won't change it. So we'll just go ahead and write this down. Now again, we're solving for x. So the only term that doesn't have an x on it is this one. So it's easy. We can just go ahead and move that away. So we'll do the opposite. We'll add d to both sides. So over here we are left with cx minus ax equals, and these are not like terms, so I'm just going to go ahead and write it down, d minus ay. Again, I'm not going to worry about standard form right now. I'm not sure exactly what all of the rules are when we have variables, so I don't want you to bog yourself down with all those rules either. So here I have two terms and they both have an x in them. So what we're going to do is we're going to factor out the x. So I have x, and what do we have left over? Well, x times c would give me cx, and x times a negative a would give me negative ax. And on this side, we did not do anything. So now what are we doing to x? We're multiplying it by the quantity c minus a. So I'm just going to do the opposite of multiplication, which is division. So I'm going to divide both of them by c minus a. And over here, anything divided by itself is 1, so that leaves me with 1x. And over here, I'm just going to leave it exactly as I see it. And there we go. Now, if you wrote it the opposite way, if you said negative ay plus d, that's fine with me. Okay, so I would take that either way, as long as x is all by itself. Okay? Now, there are two problems for you to do on your own to show me that you understand this, but remember, all of your notes have to be turned in as well. I need to see that you watched the video and you followed along with me. So skip some spacing and solve both of these to show me that you can do this on your own, okay? And all of that will be turned into the bin when you get back to class, okay?